Alright, let's check out example 2. This is our last example for lesson 6. In example 2, we want to divide a polynomial by a trinomial. And a trinomial just means we have a polynomial that has 3 terms. So this quartic is going to be divided by this trinomial. Trinomial means that it's a polynomial with 1, 2, 3 terms. So we're going to set this up the same way that we did in the previous 2 problems. Our second number, our second term is going to get written on the outside. X squared minus 2x plus 2. That's already in standard form and I don't have to add any zeros here. Divided by my quartic function. Now I want you to notice before I write it out inside my division symbol, I have a x to the 4th represented. The next one in line is x to the 3rd represented. Then I go to an x and then I go to a constant. So I'm missing an x squared in the middle here, right? I'm not representing my x squared. So I have to fill that in with a 0 so that everything lines up when I go through and I divide. So when I write this, I get 2x to the 4th plus 3x cubed plus 0x squared. That's what I was talking about before, where I need to place zeros where needed. Since I don't have an x squared here, I have to create a spot so that when we go through and divide, everything lines up evenly. Plus 5x minus 1. So in this case, since it's a quartic, every exponent from that 4 down to nothing is all represented there. Now I can go through and multiply the same way that I did in example 1, letter A, and then now you try letter B. So in this case, I'm starting off with 2x to the 4th power, and my leading x on the outside is x squared. So what number multiplied by x squared is going to give me 2x to the 4th power? So since I have x squared, I'm still missing a 2, and I'm still missing 2 of these x's from my leading x on the outside. So I know that 2x to the 2nd power times x squared is what's going to give me my 2x to the 4th. Again, you're going to want to make sure that you write that 2x squared right above the column that has your squares. And that's why we created our 0 so that we have a place to be able to do that. 2x squared times my leading x squared gives me 2x to the 4th. Multiply through to the next term. 2x squared times negative 2x gives me negative 4x to the 3rd. And 2x squared times a positive 2 gives me a positive 4x squared. I have 3 numbers on the outside, so it's going to give me 3 numbers on the inside. I have to subtract all of them in my columns. So in this case, I'm subtracting them all. Wherever I have double negatives, I can make that into a positive. I don't have a double negative there, so it just saves minus. 2x to the 4th minus 2x to the 4th cancel out, which is what I wanted. If they don't cancel out, I have to go back and relook at this number and change it because they should give me 0. 3 plus 4 now gives me 7x to the 3rd. And 0 minus 4, 0x squared minus 4x squared, now gives me a negative 4x squared. I have 2 terms on the inside, I have 3 on the outside, so I know I have to bring 1 more down, which is my 5x, and I start all over again. I need a 7x cubed. I have an x squared on the outside, which means I have a 7 and an x that are missing. So I know my number I have to multiply is going to be 7x on top of the same column that has my other x right below it. 7x now times my leading x squared gives me 7x cubed. 7x times my negative 2x gives me a negative 14x squared. And 7x times a positive 2 gives me a positive 14x. Go through and subtract all your constants in the columns. Subtracting, wherever I have double negatives, I can change that to positive. 7x cubed minus 7x cubed cancel out, which is what I wanted. Negative 4x squared plus 14x squared gives me 10x squared. 5 minus 14 gives me a negative 9x. And I still have one more term I can bring down, which is my negative 1. Going through one more time, I need a number up here that when I multiply by x squared, I get 10x squared. So I have my x squared represented here, but I'm missing the 10. So I know that I'm going to have to get a positive 10 up top. Positive 10 times x squared gives me 10x squared. 10 times negative 2x gives me a negative 20x. And 10 times a positive 2 gives me a positive 20. One last time, I'm going to go through and subtract all of my terms. Wherever I have a double negative, I can change that to a positive. 10x squared minus 10x squared cancels out like I wanted. Negative 9x plus 20x gives me a positive 11x. And negative 1 minus 20 gives me a negative 21. Since I have no more terms to pull down, I have a 2 on the inside, I have a 3, I have a trinomial on the outside, so I know that this 11x minus 21 is going to be my remainder. So I can write my answer as 2x squared plus 7x plus 10, which is what I got up top, plus, I always add my remainders, 11x minus 21 all over, my remainder goes all over the number or expression that I used on the outside. So this whole thing is my answer.